there are many of you who have not done the ones that are due today. So make sure you get those done. Anyone want to do number 1? Some of you may have took it a step further, but you only needed to write the system. You didn't need to solve that one. Thank you. So you could have made the variables whatever you wanted. Nature chose A and B. I think when I did it with second period, I used A and R. I don't use O for a variable because you could mistake it for a 0. You could, but just be careful with that. And then because it gives you 4 numbers, you are going to use all 4 numbers. The 20 and the 2260 are your 2 totals. Money goes with money, so the 125 to 95 with your variables need to go in that equation. And since 20 is your total number of pieces of fruit and these represent number of different fruit, you would add those together. Questions on that? The second one, you would also have to set up, but this one also asks you to solve. So whatever 2 variables you want, what did we use for variables? Okay, that works. And what did these represent? Number of adult tickets and number of student tickets. And then you would use those to write your equations. You are also given 4 numbers in this one, so it'll be set up very similarly. 238 and 1252.25 are your totals. Money goes with money, so 675A plus 3.5 S goes with that one. And then the other one would just be A plus S, or S plus L, either one, or whatever variables you use. Then however you solved it is fine. I'm just going to use Desmos to solve it for sake of time. So in order to solve it in Desmos, we need to have X and Y as variables. Does not matter which one you make X or Y, as long as you're consistent. If you make A X, you have to make the other A X. You could rewrite them. I'm not going to do that. And then I'm going to put both of these into Desmos. y equals 20. And 675x plus 3.5y equals, what was that number? 1, 2, what was it? I know it was about 5. And then zoom out. That's not right. That is not right. Oh, I don't know. I put 20. Got it. Okay, 230. Now it's not there. So 129, 109, and then we were looking for one specific one. So number of student tickets would be your 109. Who else got that as the answer? Questions on either of these? I forgot to go around and check your A3. So take that out. So this is a objective that, unless it's multiple choice and you can like check the answers, you have to know how to do this. So you have to be practicing this so you remember how to do it, the rules, and all that. So I'll talk about the answers and then talk about the steps, and then I'll just say the answers. So number 1 was 12x to the third times the square root of 3. You don't need the parentheses there, but if you want them, you can write them. I know it's been a while since we did radicals, but remember that there are 2 ways to do that. One is finding the highest perfect square you can divide this by. 144 happens to be that. Figuring out what that perfect square is, and then that becomes on the outside. Anything that you can't break down further stays on the inside of the radical. With your variables, there's an invisible 2 on the outside, so 2 goes into 6 3 times with nothing left over. And then the 12x to the third will be on the outside. Other way is you could factor it all the way down. Find all the factors, keep factoring until you can't anymore. With your x's, write out expanded. So x to the 6 would be 6 x's multiplied to each other. And you would find all the pairs. Anytime you make a pair, that pair gets to come out. Anytime you can't make a pair, it stays in. So then for number 2, your answer was 4x to the 5th, y to the 8th times the square root of y. 3 happened to be a perfect cube of 15. So if you put that into your calculator, you could get that number. Four was 2 times the cube root of 2. And 5 was 6x to the 4th times the square root of 3x. Questions on any of those? And then once we go through 1 through 9, I'll show you how you could check that in Desmos. So then we'll talk through the rest when we get back. You can start writing down the other answers if you haven't already. 6 was negative 2 times the cube root of 4. 7, 5x to the 6, y to the 7 times the square root of 2y. With questions like 8 and the right, 6 and 8, when when you have a negative, you have to take that out first. So it would go on the outside. So -4 times the cube root of 2. And then 9 is 4x to the 4th, y to the 8th. Excuse me, times the square root of 3. Do we have questions on any of those? Not today. So if you come before or after school, I could do that. We just don't have time for that today. So I'm going to pick 2 to show you in Desmos so you can check your answers. And I'll do 4 and 7. If you need this again, I'll come back through. So 4, since it's already just numbers, when you put it in, it's going to give you an answer. And then when you find your answer, you can put it in. So if it was multiple choice, you could use that. You can check your work with that, either or. With 7, because it has variables, you would have to make them both capitalized, add in sliders, change those numbers, and then the decimal should be the same. As long as you put in your answer, it'll also tell you, like, if your exponent was wrong, or if one of your exponents was wrong, your decimals wouldn't match. So it's not going to tell you what's wrong, but it should tell you something's wrong if they don't know. Any others we want to check in Desmos on 1 through 9? And then 10 cannot be done in the calculator because you'll have to be able to factor them or find the factors, see can this be broken down more. X to the 3rd, you could take out an x. 8 you could factor down or find the highest perfect square. Same thing with 75, so your answers are the first and the last. X times the square root of x, yes. X times the square root of x. Because you could take out a pair of x's, which would be x squared, so it wouldn't be squared anymore. Okay, then on the back is the same thing you were already doing, but with operations, subtracting, adding, multiplying. And remember that with these, it's like lead terms. So if the number inside the radicand, is the same, you can add or subtract the numbers on the outside. So 11 is the square root of 5. 12 is 12 times the cube root of 9. 13, always make sure you check to see can you simplify any of them, and the middle one you could, it would just give you a whole number. And then combine the other two. So 3 minus 3 times the cube root of 5 is that answer. 14, you can simplify the square root of 18. And then that final answer, 7 minus 2 times the square root of 2. 15, they were already simplified. So 10x times the square root of 5 plus 2. And you could check that in Desmos, your calculator also. Questions on 11 through 15? Was 9a squared times the square root of 3 plus 13a times the square root of 3. Not only are you combining like radicals or radicands, but you're also combining like terms with the a being squared and it not being squared. (17) and on, you're multiplying. So when you're multiplying, you do the outside numbers together and the inside numbers together. And if you need to simplify, you would do that. So for 17, the outside numbers become 8, the inside numbers become 15, and it's just 8 times the square root of 15. 18, it would be positive 14 times the cube root of 12. 19 becomes a whole number because the square root of 16 is 4, so just 60 is that answer. And then 90 times the cube root of 2 is the answer to 20. Would we like to check any of these in Desmos? See how to do that? Have questions on any of these?
How would, for 18, how would it not be negative 14?
You said, why would it not be negative 14? Because when you multiplied the inside numbers together, you got a negative on the inside, and you have to bring that negative out. Other questions? Major. 20. So we multiplied, we got 45, and then when you broke down 16, 2 came out of that, so then you would be multiplying the 45 and the 2. If you haven't already, take out your word problem notes from last class along with your scrap sheet of paper you were doing work on. If you don't have that, grab another one. Before I forget, next Thursday, SOL A or 4A and 4B are due. Those should be easy to do because they're just solving equations. Those are also the ones that you can easily check in Desmos. So make sure you are working on those. Okay. And on the maze, go ahead and read the one about the gym. That's the one we left off. Remember that if you need highlighters, there are some back there, but remember to put them back. more important. The more everyone participates and not the same people, the faster this will go. Cameron?
How many
Elliptical? Oh, you're talking about the question. Okay. How many minutes did she spend on the elliptical? What else is important? Lily? Major? What else is important? Lily? So let's define variables. Pick two. What do we want to call them? Alyssa? Okay. We'll make them capital. And what do E and T represent? Look at the question. The question will help you figure out what we don't know. Cameron?
would we be the amount of
Number of minutes on Trevium. And then this would be the number of minutes on elliptical. I want to say it's like a fight, but
it's
like
this,
it
goes like this.
yes, it's a workout. It's a workout. That's what it is. Okay, so let's set up our two equations. What are our totals? Alex? 1 hour. 1 hour. But this is in minutes, so how many minutes? 60. There we go. And then the other total? So just like money goes with money, amount of calories will go with amount of calories. Anyone want to take a guess as to how we will set one or both of these up? And I'm going to just do it backwards because of the way we have this one, but that's so then last we did these two problems by substitution elimination. We're going to do this one by graphing. So as we graph, if you want to have Desmos up open, you can do that because I'm going to be doing these in Desmos for sake of time. So we would have to change the variables to x and y. Again, does not matter which one you make x, which one you make y, as long as you make them both x or both y. And then we're going to write these equations into Desmos. So x plus y equals 60. And then and t and 12 equals 676. Then we have 22 and 38. one are we looking for? Y, so 38. On the elliptical, so that's the way we're going to go. So go ahead and start reading that and find the important things. Sorry, disregard what I just said. Because there's only one way to go, we're just going to skip over that. So later, when you have time to practice, if you want to go back and do this, you can. Because we already know the answer has to be 27. There's only one way to go. But read the one about the marching band. Matthew, are you reading? What is important there? Okay. What else? Lily? And what are we looking for? So let's come up with two variables. Do whatever you want. Lily? Okay. P and W, what do those represent? What specifically about them? You know that. What don't you know? How much they cost? So cost of each. Yes, at the end. Okay, and then you have 6 numbers. All 6 are going to be used. Anyone want to take a guess as to one or both of the equations? Nathan. And the second one.
E plus W equals R.
Not quite. Think about the numbers you have, the other numbers you have. We are going to be adding P and W, but we need other numbers. Do you want to try again? What was that? Now we have all 3 methods again. Which one do we want to use to solve this graphing, elimination, substitution? Elimination would probably be the best. Graphing might be, it would be easy on Desmos, but if you had to graph on your calculator, not so much. So let's do elimination. And we are looking for the cost of a quinta. Whatever. So if we get rid of W, we should end up with P. How could we make these both the same? multiply 2 here. You have options though. You could multiply the first by 6 and the bottom by 3, the first by 4, the bottom by 2, and keep going. You have so many different options. So this would become 14p plus 6w equals 402. To eliminate the w's, what would we use? Addition or subtraction? So let's subtract. 4p minus 14p would give us how many p's? 10. These cancel. 252 minus 402. Divide both sides by -10. P is 15 what? Not number of dollars. Whichever way is $15, that's the direction we're going. We'll start reading that one. Lily? What is that talking about? What is 1 inch less than 3 times its width? That's important. Because we put W equals, it'll throw things out. And we are looking for what? So in this case, you don't really have to define your variables. You can just use L and W, but if you call them something else, you would have to define. But just for habit purposes, we're going to define them anyway. We have L and W as the length. So this may seem familiar because we did problems like this a while ago when we were first learning about word problems. So we were really learning about substitution without calling it that when we were doing this. So let's first set up the length equation. 1 inch less than 3 times the width. How would we set that up? So 3w minus 1. Then we have to remember our perimeter. So we know the perimeter is equal to 54. But we also have to remember that in order to find our perimeter, we're adding up all the sides, or that's the equivalent of 2L plus 2W. So then between substitution and graphing, which one works better for this, or would work better for this? Substitution, because there's one already question. When we were solving this before, we were substituting. So put this in for L. Now, as we're substituting our final answer, we're supposed to be looking for the length. We're going to end up with the width, and then go back and find it. But that's so distribute, combine like terms, get rid of 2, divide both sides. What unit of measurement are we using here? So 7 inches. And if we look at our answer choices, 7 is one of them, but that's the width. So it would have to be 20. And you could do the math to figure out the rest. So we're just going to assume it's 20. There's no real option. So then start reading the next one. Matthew, unless you have the notes pulled up, you should be reading this on here and on your notes. What's important, Victoria? Billy? What else? Josephine? 100 points total. Anything else? Billy? Questions? And what are we looking for? So let's set up the equations. Let's first define our variables. What variables do we want to use? And what would these represent? What don't we know? Elsa? Number of each type of question, so number of multiple choice and number of short response. Then to set up our equations, anyone want to take a guess as to what one or both of those might be? Victoria. That's one. Nature, before you go, I'm going to give you this. What would the other one be? Hannah? You were raising your hand. Victoria? do graphing. So I'm going to call this x and this y and put those in and see where they intersect. So 5 equals 43 and 2x plus 3y equals 1. 29 and 14. Which one are we looking for? Y. 14. Go ahead and start reading that one. What's nice about this is going to be the last one we solve regardless, because it'll either end, it'll go to this one and we know the answers, or it'll go to this one and then it ends. So this is the last one. Because it can't go up. Important information that we found. Kristen, you had your note.
That average 60 miles per hour.
Anything else important? Silly. Victoria, how many hours do you drive? One more important thing, Hannah. Okay, so what do we want to call our variables? Alyssa? B and L, okay. And what don't we know? What do these represent? Hannah? Number of miles bend row and number of miles land row. It is hours, not miles. My bad. No, you're good. I knew it was something that. Alright, and then let's set up our equations. Anyone want to take a guess what they might be? Victoria?
60B plus 56 equals 800.
Okay, that's 1. And what would the other be? Odds. So then we have choices again. Do we want to solve this by graphing, substitution, elimination? Graphing. Of course, this way possible. So we can write down. So let's change our variables and graph this. that number? 820. Which one are we looking for? And 5 hours. But then there's only one possible answer for this. And one possible answer for this. We are done. So then in the remaining class time, you could be working on one column. You can go back to the other examples we didn't do and try to practice those. Work on Khan Academy that's due today or the one that's due next week. I'm going to pass out your review because your quiz is next class, your test is the class after that. Or you could be working on SOL A, 4A, and B. So be working on any of those things. You can work together.